Now we have learned on the fundamental trigonometric identities, and these are the identities that we use to simplify trigonometric expressions. Let's recall them together. The first one we learned was that sine squared theta plus cos squared theta is equals to 1. And if we divide all through by sine squared theta, we will have 1 plus cos squared theta is equals to cosec. Okay, cosec squared theta. And if we divide the first expression by cos squared theta, we will have that tan squared theta plus 1 is equals to sec squared theta. Now these are the three fundamental trigonometric identities we have, and we might be asked to simplify or prove an expression to demonstrate the validity of these identities. Now let's begin with question number 1. The question says that we should prove that 1 minus cos theta plus 1 divided by 1 plus cos theta is equivalent to 2 cosec squared theta. Now it's simple. The process is simple in such a way that we either start from the left hand side and move to the right hand side and derive directly to the right hand side, or move from the right hand side back to the left hand side. But the most common way, okay, is to use the left hand side going to the right hand side. So now let's prove this expression that 1 divided by 1 minus cos theta plus 1 divided by 1 plus cos theta is equivalent, okay, to 2 cosec squared theta. All we are just trying to do is to validate these three expressions. So let's begin. We are going from the left hand side to the right hand side. Let's move this. It'll be upwards. Going from the left hand side to the right hand side, we will have to take the LCM of both sides. Okay, taking the LCM, this will give us 1 minus cos theta and multiplied by 1 plus cos theta. So simplifying the numerator now, this will give us 1 into 1 plus cos theta, and likewise 1 into 1 minus cos theta. So moving on, let's simplify the numerator together. Opening the bracket with 1, we'll have 1 plus cos theta, and also opening the bracket with plus 1, we have plus 1 minus cos theta. And now let's simplify the denominator. Now this denominator is 1 minus cos theta, and likewise we have 1 plus cos theta. This should remind us of difference of 2 squared, where if we have x squared minus y squared, the result will be x plus y multiplied by x minus y. So we have 1 squared minus cosec squared theta, or cos squared theta, and we will have this to give us 1 plus cos theta into 1 minus cos theta. So this is what we have here. We have 1 plus cos theta, and also 1 minus cos theta. That's difference of 2 squared. So, and we will see that we will arrive at 1 minus cos squared theta. 1 minus cos squared theta. All right, and if you feel that is quite unacceptable because it's quite ambiguous, let's simplify further by opening the bracket. So we'll have 1 multiplied by 1 plus cos theta minus cos theta to open the bracket of 1 plus cos theta. So let's simplify the numerator now. In the numerator, we can see now that cos theta will nullify minus cos theta, and be left with 1 plus 1. And the denominator now will open the bracket with 1. So we'll have 1 plus cos theta. Opening the bracket with minus cos theta, we'll have minus cos theta minus cos squared theta. And now we'll have 2 divided by Likewise, we have that cos theta will nullify minus cos theta, and we are left with 1 minus cos squared theta, which is the expression we have here. Now, the target is 2 cosec squared theta. Now, to get 2 cosec squared theta, we have already arrived at the 2. What is left is the cosec squared theta. Let's look at the denominator. We have 1 minus cos squared theta. Now, if you recall from the first trigonometric identity that cos squared theta plus sine squared theta is equals to 1. So now, we have here now that if you find an expression making cos squared theta is subject to formula, we will have that cos squared theta is equals to 1 minus sine squared theta, and likewise sine squared theta is equals to 1 minus cos squared theta. So moving on, we have 1 minus cos squared theta, we have 1 minus cos squared theta, which is equals to sine theta. So we'll make our substitution of sine theta, and this will result into 2 divided by sine squared theta. So 2 divided by sine squared theta is 2 multiplied by 1 over sine squared theta. Okay, and this will result into 2 multiplied by 1 over sine theta all squared. Also, we recall vividly about the inverse trigonometric expression that cosec theta is equals to 1 over sine theta, sec theta is equals to 1 over cos theta. Likewise, we have that cot theta is equals to 1 over tan theta, and if tan theta, we have it to give us sine theta divided by cos theta, then cot theta will be equals to, which is equals to 1 over tan theta, will be the same thing as writing cos theta divided by sine theta. Now we are looking for 1 over sine theta. 1 over sine theta is the same thing as cosec theta. So simplifying further, this will give us 2 multiplied by cosec theta all squared, which is the same thing as writing 2 cosec squared theta. An expression that we have in the right hand side, 2 cosec squared theta, 2 cosec squared theta. This is question 1. So we have derived, or we have proved, the validity of the identities, these 3 identities, that 1 divided by 1 plus 1 divided by 1 minus cos theta plus 1 divided by 1 plus cos theta is equivalent to 2 cosec squared theta. Now let's take another example. Question number 2. We have that tan theta plus cot theta is equivalent to sec theta cosec theta. Now we can choose to go from the left hand side to the right hand side, or the right hand side to the left hand side, but let's stick to moving from the left hand side to the right hand side. Now let's look at tan theta, let's look at cot theta. If you recall from here, we have that tan theta is equals to sine theta divided by cos theta, and cot theta is equals to cos theta divided by sine theta. So let's make those substitution. That tan theta, okay, is equals to sine theta divided by cos theta, and cot theta is equals to cos theta divided by sine theta. So now let's simplify further. Remember, we are going to sec theta, cosec theta. So let's find the LCM. The LCM here will be cos theta sine theta, and the numerator will be sine theta, okay, multiplied by sine theta plus cos theta multiplied by cos theta. So let's simplify now. The numerator therefore will give us sine squared theta plus cos squared theta divided by cos theta sine theta. So moving on, let's recall from the first trigonometric identity that we have. The first trigonometric identity we have was sine squared theta plus cos squared theta is equals to 1. So we make the substitution of that here, and we will have 1 divided by cos theta sin theta. 1 divided by cos theta sin theta is simply saying 1 divided by cos theta multiplied by 1 divided by sin theta. Now let's recall ourselves as regarding the reciprocal functions. And in the reciprocal functions, we understand that cosec theta is equals to 1 over sin theta, and sec theta is equals to 1 over cos theta. Likewise, cot theta is equals to 1 over tan theta. So with this, we can say 1 over sin theta to be equals to cosec theta, and 1 over cos theta to be equals to sec theta. So making our substitution, we have this to give us 1 over cos theta, which is sec theta, and 1 over sin theta to give us cosec theta, which is equivalent to what we have in the right hand side. Now we can see that this concept, okay, is very, very interesting. Now let's take another example. Let's take another examples. And we'll call this question number 3. And in question number 3, we are asked to prove the expression that if 1 plus cos theta divided by 1 minus cos theta plus 1 minus cos theta divided by 1 plus cos theta, okay, is equivalent to 4 cot squared theta, 4 cot squared theta plus 2. Now the beauty about trigonometric identities, or the simplifying trigonometric expression, is that we might be given a very big question and then the answer will just be very simple. Okay, so it has been compressed together. So as usual, we go from the left hand side to the right hand side. So simplifying from the left hand side, we'll just have to take the LCM. So we have 1 minus cos theta multiplied by 1 plus cos theta. So moving on, let's simplify the numerator. So the numerator in this case will be 1 plus cos theta being multiplied by 1 plus cos theta. We don't want to make it ambiguous, so we are taking it one step at a time. 1 plus cos theta. Similarly, in the other side, we'll have 1 minus cos theta being multiplied by 1 minus cos theta. So one step at a time. And this will result into 1, okay, plus cos theta squared. And this will result also into 1 minus cos theta squared. And the denominator, just so as we did in the first question, that we have 1 minus cos theta multiplied by 1 plus cos theta will give us 1 minus cos squared theta, because we apply difference of 2 squared. So we have this definitely to give us 1 minus cos theta multiplied by 1 minus cos theta to give us 1 minus cos squared theta. Now let's simplify the expression further. Let's recall on x minus y squared and x plus y squared. This is algebra. So in this will give us x squared minus 2xy plus y squared, and this will give us x squared plus 2xy, okay, plus y squared. So we are going to apply x plus y squared to this, and we are going to apply x minus y squared to this. So simplifying further, this will give us 1 plus 2 cos theta plus cos squared theta, okay, plus 1. Now we are done with this. Let's move to this now, and that means we have 1 minus 2 cos theta plus cos squared theta, and we are dividing all through by 1 minus cos, okay, squared theta. Now we can see the beauty here now, that 2 cos theta will be nullified, minus 2 cos theta, and we'll be left with 1 plus 1, that is 2, and cos squared theta plus cos squared theta, that is plus 2 cos squared theta, divided by 1 minus cos squared theta. Now we are proceeding. Let's factorize the numerator by 2. Factorizing the numerator by 2, we have 2 into 1 plus cos squared theta, and the denominator is 1 minus cos squared theta. Now we are on a new page now. Let's make our analogy. But first, let's recall on the 3 fundamental trigonometric identities, which says that cos squared theta plus sine squared theta is equals to 1. And similarly, if we divide all through by cos here, we will have that 1 plus cot squared theta is equals to cosec squared theta. We are dividing all through by cos. So we have 1 plus tan theta. Okay, let's write it in the order that we know. The first thing was cos squared theta plus sine squared theta is equals to 1. And when we divide all through by sine theta, we'll have that cot squared theta plus 1 is equals to cosec, okay, squared theta. And if we divide all through by cos, we will have that 1 plus tan squared theta is equals to sec squared theta, just to avoid any form of confusion. Now, from here, we can find an expression for cos squared theta and also sine squared theta. So we know that from here that cos squared theta is equals to 1 minus sine squared theta, and likewise sine squared theta is equals to 1 minus cos squared theta. So now we have 1 minus cos squared theta, and we can substitute it here. So we'll have this to be equals to 2 into 1 minus cos squared theta, 1 plus cos squared theta, divided by sine squared theta. Now we are advancing. Let's divide all through now by sine squared theta, or let's just split the LCM. So we have 2 into 1 divided by sine squared theta, and likewise we have 2 multiplied by cos squared theta divided by sine squared theta. And remember, all we are just trying to evaluate is simple. We are trying to evaluate the fact that we have 4 cot squared theta plus 2, 4 cot squared theta plus 2. So let's simplify further. 1 divided by sine squared theta. Okay, this is sine squared theta, not sine 2 theta. So this will give us 2, okay, 2 divided by sine squared theta, and this would give us 2 cos squared theta divided by sine squared theta. Likewise, let's remind ourselves of the inverse trigonometric identity function, that cosec squared theta is equals to 1 over sine theta, sec theta is equals to 1 over cos theta, cot theta is equals to 1 over tan theta, which is equivalent to cos theta divided by tan theta, sine theta rather, and tan theta is equals to sine theta divided by cos theta. So let's make our substitution now. So we have 2 multiplied by 1 over sine theta all squared. Likewise, we have 2 into cos theta divided by sine theta squared. So we have an expression for cos theta divided by sine theta to be equals to cot theta, and we have our expression of 1 over sine theta to be equals to cosec theta. So this will give us 2 multiplied by cosec theta squared plus, this is our bracket now, plus 2 into cot squared theta. So with this now we have 2 cosec squared theta plus 2 cot squared theta. We can factorize again by 2 and say this will give us 2 into cosec squared theta plus 2 plus cot squared theta. So moving on now, let's recall what relates cos squared theta and cot theta together. This will mean we are applying the second identity function. So let's rewrite that cot squared theta, cot squared theta is equals to, cot squared theta plus 1 is equals to cosec squared theta. So we can find an expression of cot squared theta, or let's just substitute cosec squared theta into the expression. So substituting that, we'll have 2 cosec squared theta is cot squared theta plus 1 plus our cot squared theta. So simplifying further, we'll have 2 cot squared theta plus 1. So we have 2 cot squared theta plus 1, and if we open the bracket with 2, we'll have 4 cot squared theta plus 2, which is the same thing as what we have in the right hand side. So we can see how 1 plus cos theta divided by 1 minus cos theta plus 1 minus cos theta divided by 1 plus cos theta is equals to 4 cot squared theta plus 2. And all we applied was this: the first trigonometric identity functions, okay, followed by a simple modification of the first, then the reciprocal functions, and including tan theta is equals to sin theta divided by cos theta. Now let's take more examples to establish understanding on this concept.